Okay, here in lesson 3, your homework is to complete whatever we don't do in class. So since these are AP style problems, let's do questions 1 and 6. And so that means 2, 3, 4, and 5 will be for our in-class session. Okay, problem 1 says consider the differential equation dy over dx equals x to the fourth y minus 2. And it says a slope field is defined at every point in the xy plane for this differential equation. Describe all the points in the xy plane for which the slopes are negative. Okay, so x to the fourth would be bigger than or equal to 0 if x is bigger than or equal to 0. Oh no. And x to the fourth is bigger than or equal to 0 if x is less than or equal to 0. So in other words, x to the fourth, being an even power, is simply always positive. So x to the fourth bigger than or equal to 0 all the time. So the places where you're going to get positive or negative slopes will only depend on the y minus 2. Y minus 2 is bigger than or equal to 0 if y is bigger than or equal to 2. And y minus 2 is less than or equal to 0 if y is less than or equal to 2. So if you want to find all places for which the slopes are negative, we can see now that in our conclusion, dy dx is strictly negative, will be less than 0 if y happens to be less than 2. And so everywhere that y is less than 2, we will be having negative slopes. Okay, problem number 2. Find the particular solution to the differential equation given an initial condition of 0, 0. Okay, separate the variables. dy over dx equals x to the fourth y minus 2. Therefore, dy over y minus 2 equals x to the fourth dx. So integrate both sides. The ln of y minus 2 equals x to the fifth over 5 plus a constant. And therefore, when we do e to the on both sides, we would end up getting y minus 2 equals constant times e x to the 5 over 5. Okay, and therefore if we want to do the last little bit, y is equal to ce to the x to the 5 over 5 plus 2. Now, with that initial condition of 0, 0, we will now take this solution to the differential equation and use the point 0, 0. So 0 equals c e to the 0 plus 2, which means 0 equals c plus 2, and therefore c equals negative 2. And so the final answer to this problem is going to be, what we were looking for was an f of x. So f of x equals constant, which we just found, negative 2, e to the x to the fifth over 5, and then, okie doke. I thought I saw an error, but I don't think I see the error anymore, so we're all good. Okay, next, problem number 6. Oh, only 5 problems. We'll do problem number 5. Problem number 5 says, consider the differential equation dy dx equals y minus 1 squared cosine pi x. First of all, on the axes provided, sketch the slope field. Okay, 0, 0 would be negative 1 squared, which is 1, cosine of 0, which is 1, and 1 times 1 is 1. So something that's pretty close to the y equals x line. At 1 comma 0, well, let's go up to this one actually first. If we were to replace y with 1, we'd get 0 all the time up here. So I'm going to replace y with 1. Y with 1 would give me a 0 and a 0 and a 0. All of those are 0. So that's really convenient for me. Here, if I were to let x equal 1, we would have cosine of pi But 1 minus 1 is, let's see, so if I go, let's just plug in 1 comma 0. So plugging in y equals 0 gives me negative 1 squared. Cosine of 1 times pi is negative 1. 1 times negative 1 is negative 1. How about for negative 1 comma 0? So for negative 1 comma 0, we'd have, again, 1, because 0 minus 1 is negative 1 squared is 1. And then this time cosine of negative pi is also negative 1. So it's going to be negative 1, just like it was over there. Now down here, let's do negative 1 first. Negative 1 minus 1 is negative 2 squared is 4. Cosine of pi would be negative 1. This would be a negative 4 slope, so it's going to be sharp in a negative direction. Similarly, over here at 1 comma negative 1, negative 1 will still give me a 4 over here, and 1 will give me cosine of pi, and cosine of pi is negative 1, so this would be a negative 4 also. But here at 0, negative 1, at 0, negative 1, negative 1 minus 1, negative 2 squared, still 4, but cosine of 0 is positive 1, so this one would be a slope of 4. So that's what our slope field would look like at these 9 points. Okay, next it says there is a horizontal line with equation y equals c that satisfies this differential equation. There's a horizontal line, y equals c, that satisfies this differential equation. So notice if y equals c, this would mean that dy dx equals 0. So if dy dx equals 0 and y equals c, that means this top equation would now come down to be, let's see, dy dx is 0 equals c minus 1 squared cosine of pi x. And so when is this going to work? Well, cosine of pi x cycles around, so it's going to be many different values. So the only place where if we're supposed to always be equal to 0, this would force c minus 1 squared to be equal to 0, which would mean that c equals 1. So if we need to define the value of c equals 1 is the horizontal line that satisfies the differential equation. Notice also, if we go back up to our slope field, if I were to look at the slope field through 0, 1, you can see that you would get the straight horizontal line, y equals 1. Okay, finally, it wants us to find the particular solution y equals f of x to a differential equation with an initial condition of f of 1 equals 0. So let me rewrite the differential equation, dy dx equals y minus 1 squared cosine pi x. So when we want to find the particular solution, let's separate the variables. Dy over y minus 1 squared equals cosine pi x dx. Okay, solving this differential equation by integrating on both sides. This becomes, let's see, that would be the same as y minus 1 to the negative 2. So this would be y minus 1 to the negative 1 with a negative sign equals, antiderivative of cosine is generally sine, but due to the substitution we need to get a pi x, so let's do the 1 over pi. Let's check this one real quickly. The derivative of sine of pi x is cosine pi x times pi, so yep, that corrects it. Add in our constant. Now they want us to use an initial condition of 1, 0. So let me do that at this stage, I think. If I were to replace x with 1 and y with 0, we'd get 0 minus 1, negative 1, to the negative 1, which is negative 1, opposite. And then over here we'd have 1 over pi, and replacing the x with 1, we'd have sine of pi. Sine of pi is 0. 0 times 1 over pi plus c. So that would mean that c equals 1. So we would have at this stage negative, let's change the color, make it a little bit more distinguishable now that we've plugged in. We would now get negative y minus 1 to the negative 1 equals 1 over pi sine pi x, and that's plus 1. So now the last thing is to isolate for f of x, to isolate the y. So multiply through by negative 1, 1 over y minus 1 equals negative 1 over pi sine pi x minus 1. Flippy, y minus 1 equals 1 over negative 1 over pi sine pi x minus 1, and then add 1. So final answer, y, also known as f of x, would be 1 over negative 1 over pi sine pi x minus 1, and then just lop on that plus 1, and that's good enough for an AP exam.